The concept of higher dimensions has a rich historical context, evolving from abstract mathematics to physical theory. In the 19th century, mathematicians like Riemann and Grassmann laid the groundwork, defining multidimensional spaces as purely geometric concepts. The first leap into physical theory came with Albert Einstein's general relativity, which unified space and time into the four-dimensional spacetime of our reality. Shortly after, in 1919, Theodore Kaluza added a fifth dimension to Einstein's equations. He found that this extra dimension could geometrically describe electromagnetism. This Kaluza-Klein theory proposed that the fifth dimension was tightly coiled, or compactified, an idea later revived in the 1960s by string theorists. String theory posits that fundamental particles are tiny, vibrating strings. For the theory to be mathematically consistent, physicists found they required 10 or even 11 dimensions, with the extra dimensions curled up into complex shapes like Calabi-Yau manifolds. These dimensional theories, from Kaluza's 5D to string theory's 10 or 11D, demonstrate a continuous effort to find the minimal geometric space required to describe all the forces and phenomena of our universe. The Information-Geometric Entropy theory's proposition of a 14-dimensional hypersphere is the next step in this theoretical progression. Why exactly 14? Mathematical and physical reasoning. 1. 12 from the dodecahedron. The dodecahedron, and 12 faces, is the minimal Platonic solid that can tile hyperbolic 3 space while allowing non-overlapping, stable fermionic interactions. Axiom 4. Each face corresponds to one independent bosonic degree of freedom in the projection. The 12 fundamental relational modes that become the gauge fields, Higgs, and graviton components in 3+1D. 2. +1 for fermionic time. The fermionic nature of time, exclusive moments, requires an extra dimension orthogonal to the 12 to enforce the arrow and prevent stacking or overlap. 3. +1 for directional duration. The hyperbolic trade-off delta I squared equals delta tau squared minus delta. R squared needs a second orthogonal direction to give duration its positive definite, future directed character in the projection, the sign of time. Thus, 12 dodecahedral faces +1 fermionic exclusivity +1 directed duration equals 14 dimensions. This is the minimal number that satisfies stable projection of 12 bosonic modes, fermionic time, Pauli-like exclusion for moments, and causal arrow and positive entropy production. Any fewer dimensions would either collapse the structure or violate fermionic time. More would be redundant for our observed universe. A true scientific axiom must be falsifiable. The 14-dimensional hypersphere of Axiom 1 has several primary pathways to falsification. First, the discovery of more than 12 independent fundamental bosonic fields. The 12 faces of the dodecahedron map directly to the 12 observed bosonic modes. A 13th independent boson would necessitate a new geometric vessel, requiring a minimum of 15 or 16 dimensions, which would immediately falsify the 14D choice. Second, evidence that time is not fundamentally fermionic. If the arrow of time and second law were proven not to be fundamental geometric requirements, the +1 dimension for fermionic exclusivity would be unnecessary, collapsing the required dimensionality to less than 14. However, the most direct and immediate falsification would be a precision measurement of the fine structure constant A that deviates significantly from the geometrically predicted value. The IgE prediction, based on the n equals 12 constraint, matches the current codata value of A inverse at 137.035999206 with extraordinary precision. If future experiments find A outside this extremely tight band, the n equals 12 structure is wrong, and Axiom 1 is falsified. Secondary falsifiers include the discovery of a 13th bosonic field, evidence for bosonic statistics of time, or the measurement of a completely flat, non-curving geometry at short durations. Why 14D is minimal is key to its vulnerability. Fewer dimensions cannot support the 12 stable bosonic modes. fermionic time exclusivity, and directed causal duration. More would be redundant. This axiom is precisely tuned to our observed universe, making it bold, beautiful, and eminently falsifiable. If nature shows even one extra fundamental bosonic degree of freedom, or different A, the 14D hypersphere falls, and with it the entire geometric foundation of IGE. But so far, after decades of experiments, nature has stubbornly refused to deviate. Axiom 2 states that the fundamental invariant is the information interval. Dash, ear delta, E for $2 equals ear delta, ear tau $2 minus ear delta, R$2. Why this form? For us, the cosmos plays out in the 3+1D hologram of spacetime, created by the eternal interplay between duration, the fundamental time-like quantity, and relation, which includes all spatial and field displacements. Everything that exists has a defined duration and a place in relation to everything else. This hyperbolic invariant is the simplest, most minimal rule that guarantees a future-directed arrow, a causal structure that prevents faster-than-light travel, the emergence of inertia and mass, and the unification of all forces as different angles on the same curve. This is the hyperbolic trade-off. You can have long duration or large relational change, but never both without limit. The justification for this form is fourfold. First, geometric minimality. It is the only quadratic invariant that is positive definite in one direction, duration, and allows causal structure. Second, it enforces the causal arrow and fermionic time, as the positive sign on Chern delta tau $2 ensures duration is future-directed and exclusive. Third, it unifies special relativity and quantum field theory limits. Null paths, where T delta I dollars equals 0, define light cones. Time-like paths, where E delta do dollars is greater than 0, define proper time and massive particles, while space-like paths are forbidden, ensuring causality. Fourth, it derives all forces and constants, as the slope of this hyperbola gives curvature and the area gives mass via the Higgs. In short, this is the simplest possible invariant that gives us causality, inertia, and a stable projection from 14D. Axiom 2 is one of the most falsifiable parts of IGE. This hyperbolic invariant, Tuediert delta I $2 equals R delta ein hit O stulard minus R delta R$2 is immediately invalidated by several observations. First, a violation of Lorentz invariance at the fundamental level would rule it out. The hyperbolic form is the geometric origin of Lorentz symmetry, and a preferred frame or non-invariant speed would break the structure. Second, the discovery of superluminal information transfer would violate the axiom, as this would require a change in relation to be greater than a change in duration, forcing the interval to be spacelike, which is forbidden. Third, the observation of reversible microscopic time at a fundamental level would allow bosonic time and collapse the hyperbolic separation. Fourth, the failure of E equals mc squared or time dilation in extreme regimes, which are direct consequences of the invariant, would immediately prove the axiom false. The strongest near-term falsifier is the ultra-precise measurement of the fine structure constant alpha $, because alpha $ is derived from the angular geometry of this invariant on the 14D hypersphere. Any deviation from the IGE predicted value would indirectly challenge the hyperbolic form. So far, every experiment, from GPS clocks to particle colliders, has confirmed this hyperbolic structure spectacularly, but it remains the most vulnerable axiom. A single, clear violation of special relativity at the deepest level would bring it down. Imagine the entire cosmos, from stars and galaxies to black holes, emerging from just 4 geometric axioms. No extra particles, no fine-tuning, no multiverse. This is the Information-Geometric Entropy, or IGE theory. Let's see how the 4 axioms work together. Axiom 1 defines the vessel. All possibility lives in a perfect 14-dimensional hypersphere. Axiom 2 defines the rule. The only invariant is na delta E for $2, the information interval. a hyperbolic trade-off between duration and relation. Axiom 3 defines the projection. Our universe is the projection onto the simplest stable shape, a 12-faced dodecahedron. This projection is why the strength of electromagnetism is exactly alpha, at 1 over 137. Axiom 4 defines the arrow, time is fermionic. Each moment of duration is exclusive, creating the arrow of time and preventing causal loops. These axioms work in perfect concert. Start with the hypersphere governed by the invariant. Project it onto the dodecahedron and the symmetry breaks. The phase angle between duration and relation locks into two opposite poles. One pole becomes the Higgs, generating mass and complexity, and the opposite pole becomes the graviton, smoothing space. Fermionic time ensures this locking is irreversible. The moment duration becomes exclusive, the universe thermalizes, releasing the cosmic microwave background in one global burst. From these four rules flows everything we observe: the exact strength of electromagnetism, the weakness of gravity, the existence of massive particles, the arrow of time, and the cosmic microwave background. The universe isn't a random explosion that happened to work. It's the only stable projection of pure possibility, shaped by four simple rules that couldn't have been any other way. Justification of Axiom 3 in the Information-Geometric Entropy theory. Axiom 3. The observable universe is the minimal stable projection of the 14D hypersphere of possibility onto a dodecahedron, n equals 12. This axiom is not arbitrary. It is the most parsimonious choice that simultaneously satisfies multiple independent geometric, informational, and observational constraints. Below is the detailed justification. 1. Minimality and stability. Why a regular polyhedron? The projection from the 14D hypersphere must be onto a structure that maximizes global duration while minimizing relational complexity to keep the informational deficit low enough for stability. Regular polyhedra, or platonic solids, are the only three-dimensional shapes with maximal symmetry and uniformity. They tile space efficiently and have the highest number of symmetries for a given number of faces. Among the 5 platonic solids, the dodecahedron has the largest number of faces, 12, while remaining convex and space-filling via its dual relationship with the icosahedron in higher dimensional tilings. This makes the dodecahedron the minimal stable vessel that can accommodate the full range of relational configurations projected from 14D without collapsing or over-constraining the system. Connection to the 14D hypersphere. The 14 dimensions of the hypersphere of possibility are required to fully encode all possible relational configurations, while maintaining the hyperbolic invariant delta I squared equals delta T squared minus delta R squared. The dodecahedral projection is the minimal stable boundary condition that preserves the necessary symmetries for fermionic time exclusivity and the Higgs graviton duality. Other projections, for example, onto higher genus surfaces or non-platonic solids, either introduce instabilities or require additional parameters, violating minimality. 4. Empirical success as justification. The 12-fold constraint correctly predicts alpha is approximately 1 over 137.036, one of the most precisely measured constants in physics. It naturally produces the force hierarchy and the geometric origin of G. It resolves multiple cosmological puzzles, such as the Hubble tension, early galaxies, and lithium problem mitigation, without free parameters. In short, the dodecahedron, n equals 12, is chosen because it is the unique minimal stable structure that simultaneously maximizes symmetry and efficiency, derives the observed value of alpha, ensures long-term geometric stability, and requires no additional assumptions. Falsifiability of axiom. 3. Axiom 3 is one of the most directly falsifiable axioms in the theory because it makes a precise quantitative prediction about a fundamental constant. Primary falsifiability test. The fine structure constant alpha. IgE predicts alpha equals 12 over K-min inverse, approximately 1 over 137.0036, where the exact value depends on the geometric efficiency derived from the dodecahedral projection. If future ultra-precise measurements of alpha deviate significantly from this value and cannot be reconciled with small geometric corrections, axiom 3 is falsified. Current status, December 20th, 2025. The most precise measurement of alpha remains consistent with 1 over 137.02035999206, with a relative uncertainty of 10 to the power of negative 10, well within the IGE prediction. Summary of falsifiability. Axiom 3 is falsifiable primarily through precision measurement of alpha, failure of derived predictions, or discovery of a better minimal vessel. As of December 20th, 2025, Axiom 3 remains strongly supported, but it is highly falsifiable with improved precision measurements of fundamental constants or cosmological data. Justification of Axiom 4 in the Information-Geometric Entropy theory. Axiom 4. Time is fermionic. Each moment of duration, delta tau, is exclusive and non-stackable. This axiom states that fundamental units of duration behave like fermions. They obey an exclusion principle, meaning no two identical relational configurations can occupy the exact same delta tau moment. This is the deepest reason for the arrow of time, causality, and the second law of thermodynamics in IGE. 1. Why fermionic time? Geometric and informational necessity. The hyperbolic invariant delta y squared equals delta tau squared. Minus delta r squared equals constant requires a strict ordering of duration to prevent geometric collapse or infinite regression. If time were bosonic, stackable, allowing multiple occupations of the same moment, the geometry would permit closed time-like curves, backward causation, or infinite stacking of relational changes in zero duration, leading to instabilities. Fermionic exclusivity ensures causal stability, finite entropy production, and the arrow of time. Without fermionic time, the projection from the 14D hypersphere would not remain stable over long durations. 2. Link to the governing equation. The single IGE equation R equals K times delta S over delta tau. Times D inverse requires delta S over delta tau to be greater than 0 for expansion and stability. Fermionic time guarantees that each delta tau contributes positively and uniquely to entropy production, preventing reversals. 3. Empirical and theoretical success as justification. Explains the arrow of time without additional postulates. Resolves the information paradox in black holes, forbidding closed time-like curves and time travel. Naturally produces the second law as a geometric constraint rather than a statistical tendency. No other simple assumption yields a stable, causal, entropy-increasing universe. In short, fermionic time is the minimal constraint needed to make duration meaningful, causal, and productive of complexity in the projection from the 14D hypersphere. Falsifiability of axiom. 4. Axiom 4 is highly falsifiable because it makes strong predictions about causality, time symmetry, and information flow that can be tested experimentally and observationally. Primary falsifiability tests. 1. Discovery of closed time-like curves or backward causation. If experiments or observations ever demonstrate genuine time travel, closed time-like curves or signals sent to the past, Axiom 4 is falsified. Current status: no evidence exists. 2. Violation of the second law of thermodynamics. If macroscopic violations of the second law are observed, fermionic time's guarantee of positive entropy production would be broken. Current status: the second law remains inviolate at all tested scales. 3. CPT symmetry proven fundamental. IGE's fermionic time explicitly breaks T, time reversal symmetry at the deepest level, making CPT non-fundamental. If future ultra-precise experiments confirm exact CPT invariance as a fundamental law, axiom 4 would be challenged. Secondary falsifiability tests include information loss in black holes, reversible quantum processes, and cosmic observations that show signs of time-symmetric behavior. Summary of falsifiability. Axiom 4 is falsifiable primarily through evidence of time travel or closed time-like curves, macroscopic second-law violations, exact fundamental CPT symmetry, or confirmed information destruction. As of December 20, 2025, Axiom 4 remains strongly supported. No violations of causality, the second law, or information preservation have been observed, and the arrow of time remains unexplained in standard theories. This makes Axiom 4 both radical and rigorously scientific. It stakes a clear claim about the nature of time that future experiments can definitively prove or disprove.